In 99AB5, we have the figure above showing the graph of f prime. Note that this is the graph of the derivative of f, not the graph of f. And the domain of f is the set of all real numbers x such that x is between -10 and +10 inclusive. So first we're asked, for what values of x does the graph of f have a horizontal tangent? And the original function f will have a horizontal tangent whenever the derivative function is 0. This doesn't ask for mins and maxes, but whenever the first derivative is 0, we'll have a horizontal tangent. We can see that occurs at -7, x equals -1, x equals 4, and x equals 8. And that's it for part A. For part B, for what values of x in the interval from -10 to 10 does f have a relative maximum? And justify your answer. And we say that f of x has a relative maximum when f prime of x changes from positive to negative. And that will happen at x equals -1 and x equals 8. So the other two zeros at -7 and at 4, at those places the graph changes from negative, the derivative changes from negative to positive, so those would be minimum values. But we're not asked for those here. C, for what value of x is the graph, and should say for what values of x is the graph of f concave downward? Now since this is the first derivative and concavity is determined by the second derivative, how do we see the second derivative in the graph of the first derivative? It would be the slopes of the first derivative. So if we want to be concave down, then that will be second derivative negative. Concave up would be second derivative positive. So we're looking for wherever the slopes of the first derivative are negative. And this occurs between -3 and +2, or for x between 6 and 10. And that does it for this problem. It's a pretty straightforward interpretation of the graph of f prime of x. It would be different answers if this was the second derivative graph or if this were the initial function f. We'll stop here.